You think the world you see is real. Wrong, you have lived this long. Everything you have seen could be an illusion. What is even more unsettling is that some scientists used experiments to show what you do not look at does not exist. The moon, the sun, even the people around you. When you are not looking at them, they might not be there at all. It sounds like a ghost story. But this is quantum mechanics, a theory that pushed the smartest minds of the 20th century to the edge of reason. Einstein did not believe it back then. He firmly believed God does not play dice, that everything in this world is predetermined. The lottery, the weather, your girlfriend's mood, they seem random, only because you cannot calculate them. But quantum mechanics told him he was wrong. A particle can exist in two places at once. A cat can be both gone and alive at the same time. And the result is completely random. No one can predict it. Einstein was shaken. He spent his entire life trying to prove it was wrong. And in the end he lost. Lost completely. God not only plays dice, he has been playing for 100 years. And humanity still cannot catch them. So here is the question. If this world is truly random, is the world we live in real? Why does everything have patterns? The answer is hidden in an argument in 1927. That year the 29 smartest scientists on Earth gathered in Belgium for a conference. The combined intelligence of these 29 people may have surpassed everyone else on the planet combined. What were they arguing about? Just one question. Does God play dice or not? Einstein sat there, his face turning red, and he threw out a sentence. I refuse to believe that God plays dice. But Bohr shot back immediately. Do not tell God what to do. This debate lasted 30 years, until Einstein passed away, with no clear winner. So what happened next? Experiments kept proving quantum mechanics predictions were correct. But does that mean Einstein was wrong? Scientists are still debating this today. But here is the real question. If the world is random, why does the sun rise on time every day? Why does a ball always fall when you throw it? Why are physical laws so precise? This is the strangest part of quantum mechanics. In the microscopic world, everything is random, chaotic, and uncertain. But when countless particles come together and form the macroscopic world, those random effects somehow cancel out and become the patterns we see. It is like buying lottery tickets. Each draw is random, but if you buy them 100 million times, the wins will follow probability. That is how the universe works. At the core it is chance, on the surface it is order. And it gets even wilder. There is an experiment called the double-slit experiment. Every scientist who ran it was stunned by the result. The setup is simple. Take a single electron and fire it at a plate with two slits. Most people assume it goes through the left slit or the right slit. Sounds reasonable, but no. The electron passes through both slits at the same time. What does that mean? It is like walking into a room and entering through both doors at once. An interference pattern appears on the screen behind. That is the proof. But here is the stranger part. Scientists placed a camera by the slits to see which path the electron took. And the moment you observe it, the interference pattern disappears. The electron behaves and chooses one slit. What does that tell us? That observation itself can change reality. When you are not looking, the electron exists in superposition, taking both paths at once. But the moment you look, the superposition collapses, and the electron is forced to choose. Just like your girlfriend's mood, before she says anything, you never know if she is happy or upset. The moment she speaks, her emotion becomes defined. That is how the quantum world works. But scientists still cannot explain why observation has such power. How does the electron know you are watching? Even today, this remains a mystery. If you think this is already wild, you have not seen quantum entanglement. This phenomenon is like the biggest cosmic joke. Imagine this: a pair of twin particles, born already entangled. Now separate them. One stays on Earth, one is sent to Mars, separated by hundreds of millions of kilometers. You measure the particle on Earth, set its spin upward. The particle on Mars instantly responds and flips its spin downward. Instantly. Faster than light. Einstein once called this spooky action at a distance. He felt it violated relativity. But experiments proved quantum entanglement is real. In 2015, scientists ran an experiment, separating entangled photons by 143 kilometers. Measuring one, the other changed instantly. In 2022, 3 scientists studying entanglement won the Nobel Prize in Physics. What does this show? It shows that in the universe, there is a connection we do not understand. It goes beyond space, beyond time, as if the particles share a silent link. Some scientists even suggest that people might share a similar connection. Maybe that is what we call fate. Of course, this is only speculation. Science has not confirmed it. So the question returns. Quantum mechanics sounds abstract. What does it have to do with ordinary people? A lot, actually. Your phone, computer, navigation, and LED lights all come from quantum mechanics. Without quantum mechanics, there would be no semiconductors, no chips. You would not even be watching this video. But this is just the beginning. What will truly change the world is quantum computing. Traditional computers calculate one answer at a time, but quantum computers can calculate all possibilities at once and give you the optimal result. What does that mean? The most powerful supercomputers today might take tens of thousands of years to break a code. A quantum computer could do it in minutes. Even more astonishing, quantum communication is theoretically impossible to spy on. Why? Because the moment someone tries to peek, the quantum state changes. The sender immediately knows. In 2016, China launched the world's first quantum communication satellite MOSI, and in 2017 achieved a quantum encrypted video call between Beijing and Vienna. What does this mean? It means future information security may be fully controlled by quantum technology. Every country is racing to develop it, because whoever masters quantum technology first controls the future. At this point you might ask, what is quantum mechanics really telling us? Nobel laureate Richard Feynman once said, "If you think you understand quantum mechanics, then you do not understand it at all." Why? Because quantum mechanics overturns how we see reality. It tells us, at the deepest level, the world is uncertain, full of randomness and possibility. But that is not a bad thing. Quite the opposite. It gives us endless hope. Because of uncertainty, the future holds infinite possibilities. Because superposition exists, your life is not locked onto a single path. Quantum mechanics spent 100 years teaching humanity one truth: observation has power. Every choice you make, every action you take, is shaping the path of your life. Just like the double-slit experiment, a particle's state changes with observation, and so does your future. It shifts with your choices. Before you decide, your life exists in superposition, filled with countless possibilities. And the moment you choose, those possibilities collapse into one reality, a reality you create, facing a future full of infinite possibility. Are you ready to make your choice? Tell me in the comments which quantum idea you most want to use to change your life.